So welcome everyone to this new episode of the Functional Medicine Podcast. As you know, I go around the world and I'm also speaking to people who I'm interested with scientifically, but also actually some of my mentors, and I mean mentors, and particularly today, is that I'm introducing Professor Stu Phillips. Now, Stu, I have to admit, I do have a bit of a bromance with, but I actually say he's been taken over my original bromance. And I want to take you back to 1988 as a first year exercise science student with no computers or no internet. One of the key things that I loved to do was go into the library and dig out the sports medicine journal. Used to have this lovely red front to it, and it was one of the highlights of the week. And of course, one of my first bromances was a guy entitled Tarpanolsky, Mark Tarpanolsky, and he was one of the primary protein researchers. And of course, as a sort of young undergrad who played rugby, it was important, and we were all pumped up by understanding protein and protein synthesis and how that gave you bigger muscles. So that was pretty much the highlight. And Mark did loads and loads of papers on protein. But I suppose the new guy that suddenly came on the block, I mean, you've been doing this for a while, haven't you, Stu?
Yeah, 24 years now at McMaster. So yeah, and longer in school before that.
But you were the sort of new guy on the block that started producing all these papers, and we were like, wow, holy cow. And I just want to give you some of the accolades, because you're a tier one scientist as well, which I think for anyone's means that Stu is one of the most published scientists in the world in his field. And in fact, you've been cited in the top 1% of researchers in nutrition and physiology research, which is pretty full on, mate. Good effort. And again, maybe not for the people who aren't in the sports nutrition world or sports science world, but you've recently got the ACSM Citation Award. And I just want to read a quote from another, I suppose, giant in sports nutrition, which is Louise Burke, because this absolutely applies to me and many of my pals that I went to college with. And she said, every day I see evidence of people applying Stu's work. And I think, mate, every day, well, I won't say every day, but a lot of the time, I find something that you've written or your team has investigated and think that is totally applicable to what I can do in clinical practice. So thank you so much for that, pal. I think a large amount of the world in this area looks to you for what you've done, what you continue to do, and what your group does. Is Mark still around?
He is, yeah, actually. He and I, when I decided to do graduate school as a master's student, I worked with Mark intimately when I did my first project. And the first time we met, actually, I had a broken leg from playing rugby. And he had a bad car accident, and he had a halo because his neck was, in traction, and he was riding a stationary bike. And so I hobbled in with my cast, and there he had a halo on his head. And I was like, "You must be Mark," and he's like, "You must be Stu." And I think that was, I want to say 1989 or something like that. Wow. So yeah,
just when I started. So, mate, can you give us just a very brief 2 to 3 minutes background of how you got into this?
Yeah, sure. Well, first, thanks for the generous introduction. You and I were chatting before we got started. I've been very fortunate to have mentors like Mark, Stephanie Atkinson, Duncan McDougall, Bob Wolf, et cetera, that are, set me up for greatness. So I'm a product of them. And now I'm basking in the reflected glory of the hard work of my team, which is fantastic. So, and Louise's words were overly generous, I think, but yeah, thanks for that. So the main tissue that we've been studying for 20 plus years is skeletal muscle, and we're interested in the intersection between exercise, usually in the form of resistance exercise, because that can cause skeletal muscle to go up, or the lack of exercise in the opposite direction, so atrophy or bed rests, that sort of thing. And its intersection with nutrients. And really the primary nutrient has been protein, although we've investigated a few other things. And it's not that we haven't done other things along the way, But it's always been skeletal muscle in the middle, and how to essentially quantify what impact these stimuli or lack of stimuli have on skeletal muscle mass and its phenotype. You know, how strong is it? What can it do? How metabolically active is it, et cetera?
So if you can, because we talked before we came on how muscle metabolism research is really coming back into vogue, and rightly so based on what we're seeing with the science. Can you sort of, because obviously I think it feels a little bit how we used to understand the fat cell, i.e. it was just a storage site for extra calories and it did nothing. And then we've completely known that certain fat cells are completely different. And I think the more and more we understand muscle cells, we're seeing exactly the same. And we're also seeing very much the difference between, well, it's not the difference between, well, I suppose it is the difference between people who are highly active and people who are sedentary. So could you, because obviously you must be so much in demand these days, because sort of you're sitting on one of the world's prominent researchers with regards to all this understanding of muscle tissue. So can you sort of give us that brief sort of few decades of where we've actually got to, and I suppose ending with that new age of understanding of how muscle seems to be this incredible secretory organ that is signaling to the body to do things, and of course is in trouble when it's not doing that.
Yeah, I think you and I, we sort of said this, back in when I started grad school, and then moving on a little bit. I trained as a biochemist. I have to say that before I go on and say I've always been a gym guy, but I was an athlete the entire time I was growing up, and was always interested in physical activity from a personal interest standpoint. It's been interesting for me to see how sports science or exercise science, call it what you will, has now become the science of understanding this organ that was just about locomotion and big strong men, big strong women, et cetera, or leaner runners and everything else like that. Had better health, and that's good. So people should be more physically active. And as you point out, we're now understanding that skeletal muscle, it's not just the organ of locomotion. We know now it's the largest site of post-meal storage of blood glucose, so highly important in your risk for type 2 diabetes. When you distill your resting metabolic rate, still for most of us, the biggest contributor to energy expenditure, down to its two principal organs. It's your liver. I know it's small, but it's very metabolically active, and it's your muscle, much bigger, obviously. And if you don't use it, not as metabolically active, but if you do, then it's a significant contributor to energy expenditure. And it's a site of these myokines, the source of these exercise-generated cytokines that we now know are extraordinarily beneficial, and probably explain some of exercise's benefits beyond just your heart, your lungs, your muscle, and it signals lots of other tissues as well. So it's been a great time to be around that, to see a sort of I don't know if it's a renaissance or just a naissance per se, to a new age of understanding of the importance of skeletal muscle. Is not just it wasn't just liver, and as you say, and then the fat was just a depot, and now we know it's metabolically active. So a real interest in an increase in understanding of what the tissue means, and now foreshadowing into some of the stuff into aging and patient populations and those sorts of things. So yeah, really interesting time to be involved in science.
Can we do a little tiny dig down, if it's okay with you, just into just a little bit around myokines? Because I can remember, we must be going back to about 2010, 2011. I remember reading Bente Pedersen's paper where there was this suggestion about the muscle potentially has this secreting activity where it's secreting all these molecules, if you like, called myokines, and they're probably going to be highly beneficial both locally and systemically. And that was my first recognition of, well, what the hell are myokines?
Yeah, well, I have to lean on my friend Mark Tornopolsky here, and he would prefer that we call them exerkines, because they go up with exercise. We're pretty sure some of them are coming from muscle, but I think to your point, I mean, they probably have an action locally on the tissues, either back on muscle itself, so what we call autocrine, or in close proximity to muscle, or paracrine. And then, as you say, there's a systemic response, so that's the endocrine side of things. But yeah, I mean, I think it was a revelation for most people to realize that skeletal muscle was a source of these signaling molecules, which were having effects that were, distant, organ to organ. For example, chat or crosstalk, as it's called, and responsible for some of these effects of exercise that we're like, why do people's, and you name the organ, and it's just about everything tends to benefit when people are more physically active. So really, yeah, groundbreaking discovery on Dr. Pedersen's front.
Because I think that's also, I mean, you're in the scientific world, right at the coalface. We're in the world where we're trying to interpret what the scientists are doing, which I have to say, you do a pretty fantastic job of the translation. Because I think that's some of the key, isn't it? I mean, you can read some incredible papers, but they're read in a way you're like, but I just got no idea how I'm going to translate this into the patients on a daily basis. You've always done that brilliantly.
Thank you.
Yeah. I mean, I think about some of this because many people still, general public, look at exercise from a point of view, it's just simply something that we can utilize to help us lose weight.
Yeah.
And really, can you just explain where we are scientifically with that? Because for many people, it's probably not the best single modality to use with regards to weight loss, but it seems to be pretty much one of the most single things that we could do that is likely going to be most beneficial from a health perspective.
Yeah, I mean, I think when people talk about weight loss, it sort of makes sense. We've got energy expenditure on one hand, and so that's the physical activity too. And we've got energy intake on the other hand. So, pick your favorite weight loss theory, but I mean, everything from a weight loss standpoint runs through energy balance. So, from my perspective, the question as to can exercise help you lose weight? The answer is yes. The question of does it help you is entirely dependent on, how much you still take in on one side and expend on the other. So it's hard work to burn the number of calories that are in a single, muffin or a donut or something. And so I think it's much easier to over ingest the food. And so my sort of trite phrase is that, muscle and fitness is made in the gym, weight is lost in the kitchen. So it's a lot easier to cut calories through food intake going down than it is to do more energy or more expenditure in exercise to burn calories. But, from our standpoint, the evolution of our understanding of all of that is really now that skeletal muscle and exercise and everything is much more than just weight loss. And so, I've tried to take pains to point this out to people that, if we just focus on weight on the scale, and not that that's not an important physiological outcome, but we talk about mental health, quality of life. We talk about, life extending capacity, health span, reduced risk for, and just about every chronic disease falls under that umbrella. I've said before, it's almost embarrassing to talk about how good exercise is for you, but weight on a scale is not easily lost through increasing the amount of exercise that you do. And I'll agree with that.
And so going back to that, I can remember when, again, we're probably about 10 years ago now, I think there was a paper that came out in the Lancet, which was discussing the combination poly pill would be the best from a health perspective.
Yeah.
And then actually I think they were Spanish sports scientists, immediately came out with a paper that exercise is the real poly pill. And they cumulatively went through all of the mechanisms that we're seeing with exercise. So why do you think I actually think it's probably because I think maybe, I'm not going to say big pharma, but industry is now looking at exercise as maybe it's something that is more easily be sellable, and maybe that's why it's more in vogue. Even, I'm looking at John Hawley and Michael Joyner's paper. They wrote with a couple of other colleagues, Integrated Biology of Exercise. I think it was 2014 in the Journal of Cell, which is talking about integrated biology of exercise and how I think over the last few decades, exercise has gone from this single modality to suddenly how it completely mixes systemically with everything else. Do you think that's part of it? Is that there's nothing that exercise can't reach?
Yeah, I mean, I think the paper you're talking about with John and Mike is a great example of understanding. I mean, to understand exercise, you have to be an integrated physiologist, because you can't move your muscle without generating a motor signal. So you have to understand brain function, and then you can't move a muscle without understanding something about nerve conduction, and your heart and your lungs immediately have to respond. So you have to be a cardiorespiratory physiologist to understand how those things integrate as well. And I'm a big fan of, talking about why is it that things like aerobic fitness or functional tests of, getting up and standing up or balancing on one foot are so ridiculously good at predicting morbidity and mortality, even compared to, blood pressure, cholesterol, smoking. So traditional risk factors that we know have a really deleterious consequence in the case of smoking, or high blood pressure, or high blood lipids. And then I can point to a physical function test and I'm like, it's just as good, maybe even better in some circumstances. And I think it's because it crosses multiple physiological systems. So any weakness in the chain anywhere along the way, so your heart, your lungs, your muscle, your nerves, your brain, would show up in that test. So it's the only thing I push both Mike and John on, who are both aerobic guys, and not that I'm not, is to say, and you need to lift some weights. And they're grudgingly, I think both of them, as maybe they've gotten a little bit older, they realize that strength is ultimately going to matter as well. So we're trying to push back on that, on the narrative that it's 150 minutes a week and everybody understands that one. And then it's like, and it would be beneficial. I'm like, and it would be necessary to do some form of strengthening activity on at least 2 days a week, for example.
And do you think, I think that's probably because, we start with Ken Cooper, don't we, down in Dallas, where we're starting to learn about aerobic fitness. And do you think that's just simply because traditionally most sports science research was aerobic based and less strength based? And I think about stuff like so we do a lot of genomic screening. We do a lot of work with regards to neurodegeneration, early aging of the brain. And, one of those key gene variants is in BDNF. Now, I think about it, well, there's certainly plenty of evidence to suggest that aerobic activity is going to stimulate BDNF, and it's going to be much more important in those people who have those gene variants. But I'm pretty sure that probably resistance exercise does the same. It's just that we just haven't bothered doing the research yet.
Yeah, I couldn't agree more. I've mused in the past. I've even spoken in symposia to say, the title of the talk is, what if Ken Cooper were a lifter instead of a runner? And not to diminish. Well, here's the interesting part is, and I sample, I cherry pick a quote from Ken Cooper when he was younger that says something to the effect of, I'm not dismissing resistance exercise as an important mode of exercise, so long as it doesn't take the place of aerobic exercise. And I have to admit that I probably could revise that quote now, because my understanding, again, from listening to people who work with Dr. Cooper, they say he does a lot more weights now than he did when he was younger. But clearly he's quite a bit older now. But yeah, the volume of work that was generated from the Cooper longitudinal aerobic study has been enormous, and it's been those are landmark studies showing us just how important cardiorespiratory fitness was. And it's been a mountain of evidence since. We lack the same data for resistance training, but I've tried to make the point that, as opposed to two things, that this is aerobic and this is resistance, and they're out here, that health-wise they're actually much closer together. And it's always the case that if you take somebody who does nothing to doing something, and it doesn't really even matter if it's aerobic or resistance, that they go and they move on a regular basis, that's the biggest reduction in risk. And on a population level, I get it with certain drugs that are going to do one thing or another. If we nudged X% of the population to do something to become less sedentary, the health effect knock-on would be enormous. So,
and I absolutely agree with you with well, I think this takes me back to, I don't know if you know Dr. Jeff Bland. He was the sort of,
Yeah.
Well, he was if you like, the godfather of functional medicine, and he tried to diagnose functional medicine, and he was basically saying, well, it's trying to understand the loss of function across many organ systems. And, you know, I think that is a really good, almost like definition of aging, if you like. And the key to that, again, is when we're looking at what you were saying, is I have a part of work where it's looking at early stage neurodegeneration, early stage Alzheimer's, and of course the sit to stand test is incredibly well validated. The grip strength is incredibly well validated, and I still think, I honestly think it's because it's just not sexy enough. It doesn't cost anything to do, and therefore that's why people don't take that much notice of it. Because I mean, you can go on expiratory volume in 1 second for lungs. I mean, you name it. I mean, you know, there are so many physical function tests that are highly associated and clinically relevant to aging, which, mate, I want to move on to, because one of the key things I wanted to talk to you about is, with a sedentary population, with an obesogenic environment, with an aging population, we need as much muscle mass as we can as we age. And in fact, I want to quote one of the quotes you said to me when we were tagging on social media many years ago, is that you said, you cannot go old quietly. So can we talk about the problems with regards to the loss of muscle mass, and a term that we use, sarcopenia, as we age?
Yeah, I mean, you know, sarcopenia, I think it's now about a 40-year-old term, and the original definition was based solely pretty much on muscle mass. We've evolved a little bit in our understanding, and are now thinking that, you know, the function of that muscle is particularly important and predictive of future events.
Definition dynapenia?
Yeah, so that's Dr. Todd Manini. He's added that term, dynapenia. So it's essentially a decline in physical function, or something that's outwardly manifest by, you can't either rise from a chair, do a certain walk distance, etc. And now the ridiculously good prediction of, you know, gait speed, how fast you walk.
Absolutely.
So you know, I think all of those things, you're right. I mean, they aren't sexy. Wouldn't it be disappointing to go to a doctor's office and just hold a hand grip dynamometer and squeeze, and the doctor goes, oh, you know, you're in trouble, as opposed to, well, what do you mean? You know, you need to take some blood or run some tests or something. And he's like, well, you know, I just did. You know, there's something unappealing about that. But you know, I think again.
So I think, well, I think this is what we were saying about how there's a new age of exercise scientists coming to the forefront, because you know, I can think of quite a few where that is properly sexy, because you can't argue with the validity of what the science tells you to do it. You know, it's a real hot off the press, but it's been recirculated again after, you know, 25 years of when it was already developed. And, you know, suddenly they're getting back into it. Oh, wow, it's this new thing. Sit to stand test for, you know, a diagnosis of Alzheimer's. When other doctors are spending $2 or $3 grand in the lab to try and get some biomarkers.
Yeah, I mean, you know, the appeal of biomarkers would maybe be able to pre-identify somebody who is at risk for, and you know, insert your chronic disease here, well before they develop symptoms, you know, and I do 100% buy that the variability in physical performance tests maybe prevent them from being overly useful until we come up with a hard and fast, you know, this is a so-called cut point. And, you know, there have been projects that have tried to establish those cut points to say below this amount, et cetera, but we haven't operationalized those definitions well enough, I think, for people to use them in everyday practice. So, you know, you and I can agree on it. And I think a lot of the broad exercise physiology community would agree on it. And even some probably physical medicine rehabilitation geriatricians can probably buy into the concept, but you know, the average general practitioner, your family doctor, probably wouldn't have as good a grasp of what that means. And it's a pharma-driven paradigm. We treat problems and alleviate the symptoms of the disease, but don't address the underlying cause. And that's where physical activity and exercise really, you know, it's it's the trump card, right? And you're just like, okay, well, this does everything.
Yeah.
But
you got to do it.
It takes work. Yeah, you got to get up and you got to do it, and it's better if you do it on a regular basis, and it's better if you do it for a longer period of time. And all of these things are, for a lot of people are either demotivating or they have no motivation to begin with. And I'm somebody who loves exercise, and there are even days where I think, I don't want to do this workout, but I do it.
Yeah.
I think if I don't want to do it, like, how does somebody who's doesn't appreciate, understand whatever is or have time to do exercise, what are they going to do? So I acknowledge that it's easy to say to do it, but it's in putting it into practice that's diabolically difficult. So
agreed, mate. Can we jump on to why it's more difficult to produce more muscle mass as we age, why we need potentially more protein as we age, the loss of signaling and muscle protein synthesis. Again, this is a key aspect of trying to get those people from 40 onwards who come into the clinical practice to get that understanding that, maybe we're going to have to change the balance of some of the major macronutrients in your diet. And here's the reason why.
Yeah, I mean, in short, muscle is made up of protein. Protein is made up of amino acids. And I always use the analogy, and I think it works fairly well, is to say, imagine that your muscle is a brick wall. And, one end, there's bricks going into the wall. Those are the amino acids going into the muscle protein. And at the other end, the bricks are being taken out of the wall. And people are like, well, that doesn't make sense. The wall wouldn't change size. And I'm like, actually, you're right. Once we're beyond probably age 20, our muscle mass kind of stays the same. But at a certain point, and this is the big money question, when muscle begins to decline. And so the rate at which bricks are being taken out is chronically greater than the rate at which the bricks are being put in. I think that it starts for some people in their 30s. If they're physically inactive, they don't eat right, et cetera, and they're probably at greater risk of some sort of functional decline later in their life than somebody who's physically active. Definitely for most people in their 50s, it becomes very difficult to stop the decline. And so, I'm there now, and fully admit that it's my event horizon now is not about, trying to improve my performance, because my performance is always going down, but it's trying to slow the decline. So the main issue as we get older is the efficiency with which we put bricks into the wall is not as good. And so we call it anabolic resistance. You're resistant to the normal anabolic effects of protein. When you're young, no problem. Physically active people, awesome. Like young physically active people, obviously great muscle mass, tend to be leaner, et cetera, et cetera. As you get older, that process slows down. Like every physiological process as we get old, there's no question about that. So, it shouldn't surprise people. People want to push back against it, and hence my comment, push back, rage against the dying of the light, so to speak, to, quote Dylan, and try and do as much as you can to slow the decline, because the theory is that at least at some point, if you have two individuals and they're both going down, this person here will hit a threshold where they just have a hard time doing things a lot earlier than their life than somebody who's going down at a slower rate or had more to start with. So
what does that look like on a daily basis? Let's take an average, well, it used to be the average 70 kilo man is what we used to do in the early 1980s at uni. We're going to use the average 50-year-old 70 kilo man. I don't know whether that's been adjusted upwards quite a bit, but again, we know, and I've read lots of papers with regards to the relevance of really focusing on the amount of protein. And also, I think what's changed is, so I don't know whether you can see this, but you're going to laugh. Do you remember this book? I've still got it. Ivy and Portman.
Oh, yeah.
Oh my goodness. When that came out, I thought that completely changed the world. That was my secret supply that only a few people knew about, because we imported it from the US. and we thought we had a big start on everyone else. And that was a pretty spectacular book at the time about the importance of maybe timing proteins to get even more beneficial effect. But I'm also looking at Alan Argon's and Brett Schoenfeld's Nutrient Time Revisited paper that they did in 2013. So can you just give us sort of what we would consider good amounts for the average 70 kilo person? And do we need to do it in one go? Do we need to split it through the day? Should we take lots before we go to sleep?
Yeah, a lot to unpack there. Let's just say, well, I'll start out with the nutrient timing book. You're right. I mean, that book, I was in the game when that came out, and it was all about nutrient timing. So exercise makes your muscle receptive to storing fuel, to building, et cetera, et cetera. So the stimulus is after you've stopped exercising, it's like, okay, let's recover and let's get better, if that's the right way to put it, than we were before. So restore carbohydrate, replenish fluids, obviously, and I say repair, and that's the protein side of things. And so repair and remodel, get better. If you're doing aerobic work, build more mitochondria. If you're doing resistance work, build more myofibrillar proteins. I think the message around the timing is that the window, the post exercise window, is open for a long time. I've seen a group recently call it a garage door or a garage door, as you might say. It's big. The window's open for a long time. You don't need to carry the shaker bottle around. It's unless you're worried about the last microgram of muscle. So most mere mortals just make sure that you eat sometime after you exercise. Could be as long as 24 hours. Okay. And I know for a lot of people they go, wow, I'm like, that's the evidence and the data we have. The question then becomes of how do I eat, what do I eat, everything else like that. So my big picture take home is I think the biggest variable to dial in is the amount, and the current recommended dietary allowance or recommended nutrient intake in the UK is around 0.8 grams of protein per kilo per day. And I think, that should be shifted up to at least 1.2 is the baseline. And you can get benefit up to, I think, around 1.6. You might get a little bit more at higher intake. So that's twice the recommended. So I don't think the recommended should be recommended, because I think optimal function comes out at around 1.6. So that's the first thing to dial in. The question then becomes, as you said, can we get it all at one meal? I don't think so. I don't think that's the most efficient way of doing things. We have a hard time handling protein. We can absorb it, we can digest it, we can digest tons of protein, but how we use it is better when it's done in sort of discrete meals per se. So, 3 or 4 eating occasions, protein at every meal. So breakfast tends to be the lower protein meal. Try and get it at that meal, try and get more at lunch, and then try and maybe, dinner, which is the big meal of the day, take some of that protein and add it back to some of these other meals. So that's probably, the next variable. And then after that, people get into, I'll call it the nitty gritty, which is, is this protein better than that protein? Yeah. And, here's where my message on that it's changed. We've generated some of the data that's forced me to change my view on this. It used to be animal source proteins were way better in quality, and that made a huge difference. I don't think that that's the case as much anymore, but I do think when you get older, when that starts, I'm not sure, but at least into your 60s, the quality of the protein begins to matter a little bit. So 1.2 to 1.6, at least 3-4 eating occasions, more higher quality, so animal source proteins, dairy being the highest, really hard to beat dairy in terms of quality, and try and get that at every feeding occasion if you can. Beyond that, then it gets a little bit more granular. People begin to talk about which amino acid, and I can probably unequivocally point to leucine as the key amino acid. And after that, you just have to have the other ones around, the essential amino acids. And but you can go pretty deep into the details with this. But I do think if you can get the quantity dialed in, and at least 2, maybe up to 3 eating occasions a day, then you're in good shape.
So leucine seems to be the major player for
Mm-hmm.
the amino acid that talks to everything to say, okay, let's get rebuilding, let's be anabolic. And I think so. And I think sometimes this is where the sort of hard science gets a little bit caught. I wouldn't mind getting your view, because of course there would be many people who may listen to this and say, how can this professor say that dairy is a great source to get protein? You know, dairy is pro-inflammatory. And listen, mate, I've always been a huge fan of really good whey protein. You know, I just see too many positives against any real negatives on that side. I don't know what your thoughts are around that.
Yeah, I mean, one of the things that I've come to realize is that when it comes to dietary recommendations, there are, exercise is a little easier. Do it, and that's good. Food is, everybody's got an opinion on it. And all I'll say is that exercise is the forgiver of many sins, if that's the right way to put it, in that some of these so-called inflammatory profiles that are associated with certain dietary patterns completely disappear in people who are physically active. It's activity that drives your inflammatory status much more than your diet. And, so I'm sort of couching my response in that. Not to say that, plant-based diets and vegan lifestyles aren't very healthy ways to eat. I think you just have to be a little bit more judicious about how you plan your protein intake, but that's getting easier and easier with the food choices.
Yeah.
So I think 10, 20 years ago was hard to make the transition to those sorts of dietary patterns because the food choices just weren't as great. Now that's not the case. So, lots of research to support dairy-based proteins. And
so let me jump onto the next bit, which was, there's this always, isn't there? I think when people ask me, well, that goes against what you were saying before, and that's like, it's because you need to be specific for the argument we're talking about. And I want to try and do this here, because this is the argument about where does protein fit with regards to the longevity model? And as I said to you, let me tell you where this sits, because I can remember Walter Longo coming to London. He was at the RSA, and he gave this brilliant speech. And to be fair, he's a pretty serious scientist, published in tier 1 journals. So and I'm just a clinician in practice trying to work out what the hell's going on. And I can remember he was very strict with regards to protein amounts and types of proteins. And I put my hand up and said, look, this is all well and good, but most of my patients that I see are in their 40s and 50s, they're sedentary, they're likely sarcopenic. And I feel based on the research, I need to give them more protein, not less protein, because I'm more concerned about the loss of function and loss of muscle mass, but also from a point of view of the sarcopenic effects. So where do we stand with all of this? And again, it's probably because, well, maybe that's saying it's a nuanced question from a point of view, well, why are we doing it? Are we doing it because we want to build performance, or are we doing it because we're ultimately concerned with longevity? Or is there a middle ground?
So first, my writer statement is, as soon as I start talking about protein and longevity, is to acknowledge that, people like Walter Longo do great work. And I think the animal models that he employs in his work, and a lot of other people besides, and so there's restriction not just to protein, but of a single amino acid that's in protein, like methionine. And restricting this amino acid and that amino acid, and these rodents in cages live longer, and we're suitably impressed by those data. So, and mechanistically, I don't doubt that the effects are real. Like, they're there, absolutely.
Agreed. And it's not just that, isn't it? His fasting protocols have shown some pretty serious stuff with regards to stem cell regeneration.
Sure, absolutely, and not debating that at all. I think that the question becomes is how translatable are those scenarios to human beings, and then and what's the practicality of using a mouse that lives in a cage that's completely isolated from any stressors, et cetera, And, and you think about the complexity of our living systems and the global pandemic that we were just all exposed to, we're still dealing with, and what it means to, have stressful, I'll call them just stressful catabolic events, hospitalization, sickness, illness, et cetera, disuse events. And in those times, which you experience at much greater frequency as you age, you need to have a reservoir of muscle to draw on. It's like functional reserve. And, so from that standpoint, I think the model that they have of just letting these mice live in cages, they're usually, if not always, not exercising, they don't get access to a running wheel or anything else like that. Mice, give them a running wheel, they can run 10 kilometers in a night. They're like a mouse, which is, I don't know what that translates into a human, but they're pretty active critters. And in those circumstances, what do those data really mean? And I'm a little bit jaded on the translatability. Now, I do know one paper that Walter's a senior author on, and they have some human data in there taken from the NHANES survey. And all I can say is, and I've been saying this for too long now, but we've got data that shows that their findings are not what we find when we look at NHANES data, protein intake and longevity. And even if you do a review of the literature, and it's all observational, of course, in human trials, protein intake is not a predictor of morbidity or mortality. So, take that for what you will, but I'm impressed by the science. I think the science is an interesting fundamental question that we could talk about as to protein's role in triggering anabolic processes in aging. But even Walter's own data points to the fact that if you're older, you do need more protein. And he would be the first to acknowledge that. And although his take is that it should be plant-based protein, and then I probably would agree. We could all stand to eat a little bit less of something or another. But the real fight with food is being fought over things that I don't think matter as much. Meat, eggs, milk. The chips, the biscuits, everything else, the crisps and stay away from that stuff. That's the true enemy, in my opinion. So it's maybe a bit simplistic, but I do think that being physically active and eating whole, or I'll call them real foods, is not a recipe for disaster. But if you eat all the processed stuff that goes along with it, oh man, this tastes good, and you're like, yeah. It's somebody in a food science lab is going, it's working,
I think the risk of all that, isn't it, is that you end up going down one pathway and thinking that is the only pathway. I see this with dietary choices, whether you want to be vegan, vegetarian, whether you're a carnivore aspect, and it just sort of thinks, well, you know what? The right food for the right person at the right time makes a lot of sense, but actually that might not be the right approach at certain times in your life. And I think that's what Longo's research showed, didn't it? If I remember, it was showing that I think between the ages and 40 of 60 is where maybe you might want to think about changing your protein, but actually once you are past that, then you really probably need to eat a bit more. And I think about that in many ways. I think about that from a point of view of digestive capacity. Stuff like accolades or hypocalidria, we're just not being able to get enough gastric secretions going to actually allow us to, break those proteins down. And I also think about, I can remember reading a recent paper, just the amount of protein needed on a daily basis just to keep the gastrointestinal tract working as well as it can. And you're like, holy cow, and how the body partitions what it needs most. And then muscle seems to get the sort of end of the scale if there's anything left. So even more, I mean, for me, I'm more and more convinced that at least what I'm going to say, optimal protein requirements are absolutely essential as you go old.
I agree. I mean, I think people think that muscle is some enormously important tissue, and I'm like, look, if you're really sick and you're laying in a bed, your body will break down muscle like crazy to get the amino acids at least. Like there's far more important proteins in your body than muscle, I'm afraid.
Yeah.
And and that's really where the concept of that functional reserve comes from. And so to withstand challenges, health challenges, opportunistic infections, etc., is really about preservation of muscle in those scenarios. And for me, and you probably would see this within your patient group, those are watershed moments for older people. If everybody ages and doesn't have any of those events, they actually do fine. But we know the numbers, the percentage of people that are obese, the percentage of people with type 2 diabetes, the percentage of people who will have some form of cancer, and you layer those things on top of each other, nobody is a human being, or very few people fall into the category that are really the physiological equivalent of the mice that are being studied in all of these scenarios.
So leads me on to pretty much my second to last sort of subject, which is sort of related to Longo's work, but is very in vogue at the moment with regards to the nutrition nices. And oh God, I hope I haven't put group out there, but autophagy and mitophagy, which are cool things that seem to be quite highly associated with when the body, if you like, decides, because there's probably not a lot of fluid around, that maybe we should do a lot of tidying up and regenerate and kick out lots of cells. So Stu, can you just define those? Because we were talking before, weren't we, before we came on the recording, about mitophagy, which is really quite new science. I mean, I didn't even know that it existed until about a year ago.
Yeah. Yeah, it's as if, these processes, we've known about them for some time. And I mean, I think it comes back to the concept of, if proteins or, in your muscle or a brick wall, we talk about constant turnover, amino acids going in, amino acids get, so your muscle protein is being made and broken down at the same time. Seems odd, but if you think about it, and if you want the wall to operate as well as it can, wouldn't it be great to have somebody putting new bricks in and then somebody taking old damaged bricks out? And that concept is the same when we talk about autophagy, which is simply the breakdown side of things, about degrading proteins or protein structures, which is mitophagy, and the structure is mitochondria. And what we're talking about is eliminating or getting rid of, as you point out, all of the damaged proteins, and take out the trash, the garbage, the rubbish, whatever your favorite term is, and those are the things that they're not working as well. We need to get rid of them. If we don't, the system's not going to work as well as it should. And there's all kinds of things that happen, particularly with increasing frequency as we age. There's oxidative damage. There is shortening of our telomeres and our chromosomes. All of these things are, the system is breaking down. And so we need to sort of keep up the recycling part of it, or the taking out the garbage and the damaged stuff, or otherwise when it accumulates, that's not a good thing. And that, there's lots of human diseases which are typified by aggregations of these proteins and, damaged proteins. And, that's not a good thing. So I think the easiest way to sort of talk about it is both of those processes are around taking out the garbage, so to speak.
And I suppose it's quite a key area in the aging research currently, isn't it? Is that maybe that, and again, this is a bit like, I suppose, Longo's research, is the question of maybe sometimes we should just give the body a break from a point of, well, again, that's an interesting question, because I think about that. I think about people who, and maybe this is slightly different, who want to do a detox and basically don't give themselves, again, I think that's an emotive word, give themselves, they just don't eat for a couple of days. And I think about that and think, okay, so you're asking your body to do this massive job that probably needs to turbocharge itself. It's going to need a massive amount of certain amino acids and vitamins and minerals to be able to do that. Is that a smart thing to do? I mean, I don't know, but I think there's probably some degree of argument that occasionally missing meals is maybe a smart thing to do, just to give everything a break.
I think the point around, this intermittent fast or whatever you want to call it, time restricted feeding. I mean, there's lots of the, people say, well, they're different. And I'm like, to me, they're all just variations on the theme of when you don't give the body substrate, the body gets much more efficient at recycling things that it holds on to. But what it does in those situations is it really upregulates the degradation or the taking out the trash side of the equation. And so, if you imagine most people in a westernized society, they're overfed and you could argue undernourished, but they're eating like a lot of food.
Yeah.
And in that scenario, then when you take that away and you improve the autophagy and getting rid of or mitophagy, getting rid of the damaged stuff, that's not necessarily a bad thing. Like, you don't have to be anabolic all the time. I know that would be horrific if I were talking to bodybuilders, but somebody in their 80s and 90s, that's not maybe a good thing. But in your 50s, 60s, and 70s, it's not necessarily a bad thing either. So I think there's a time for it. I think it can have, and I wouldn't argue again with the science around what it can do. The utility and how it really translates, how it plays out into the big picture. Does it really improve your health span and your lifespan? I think that those, talking to some people, they'd say, oh, absolutely. Yeah, of course it does. And I'm still, let's just say for now, I don't argue against it. I'm just unconvinced by what it can really do for you.
And I don't know whether that's maybe the new world we hang out with regards to systems thinking. And, I think I've done a reasonably good look at this, and I don't see any increased value, certainly from a point of view of weight loss or weight control, with regards to just generally calorie restriction and something like intermittent fasting. I don't think I've seen that to suggest any is better than the other.
No, and on that front, like, they're entirely equivalent. And so that's one indication. And then people talk about, animal studies, and I'm like, yeah, but this is all controlled, and it's as if the animal has no will. So you give it food, or you give it less food, or you feed it this and you don't feed it this. And I mean, human beings intrinsically don't make those choices as well as animals. So the translatability of it in terms of putting it into practice, I think is tough at this point.
So, Stu, I know you've got to go. So I'm going to get some summaries for you. Let's imagine that I'm a 52-year-old bloke who's just trying to age as well as he can, taking exercise, hopefully, pretty much on a daily basis. What would be your tips for me around exercise and sort of protein intake that I can take away and I can apply on a daily basis? And we didn't even get into the systems effects, maybe, that the gut microbiome is part and parcel of what makes us maybe fitter. Yeah. Is there a relationship with that? Maybe I could poach you for another one on that one. But what would be so imagine I've got to go in and say, after speaking to Stu Phillips to my patients tomorrow, and here's what he's basically telling me to do, or telling you to do.
Yeah. The first thing is, be as physically active as you can. Try and meet those prescriptive guidelines we talked about. I'll just say 150 because most people talk about that, or 75 minutes if you're doing higher intensity stuff. You're going to need to be strong at some point in your life. There's going to be a crisis of strength, we'll call it. And you're going to want to have the reserve that you have, and that's muscle and the strength that goes along with it. So lift some weights, or lift your own body weight, or whatever it is. Do some push-ups and press-ups, and try and be as strong as you can. Protein wise, it's higher than most people think. Not that you can't live on less, you can, but I think the optimization of health comes at intakes that are about twice the RDA. And then beyond that, it gets pretty spiritual and philosophical, right? Have a good circle of friends, et cetera. Make your life about something that has purpose and gives you a reason to get out of bed. And I think you'll do okay with those things in place.
Stu, as I said to you, tier one scientist. Don't get many of these on the podcast, mate. Thank you so much for your time. It's
My
pretty
pleasure.
much been invaluable on that side.